Welcome to Spark Academy, dear students. I am Nityanand Ghosh, physics faculty here. So today I will be discussing motion of a particle or a body in straight line. In a straight line means it is one dimension. The moment it becomes two dimension or three dimension, it is called motion in a plane. So basically, I will be discussing about motion of a particle or a body in a straight line, one dimensional, or with gravity, against gravity. So I will be discussing about what are the physical quantity that we have to discuss under this particular topic. You have to know what is your speed, what is velocity, what is average speed, what is average velocity, what is instantaneous velocity, what is acceleration, what is instantaneous acceleration. If a numerical problem is given, how you find out? And of course, you have to know the equations of motion of a particle or a body in a straight line under gravity also. And then there are some problems which they ask about, let's say, involving whenever a body is moving in a straight line, it may go and collide with another body. So collision takes place, kinetic energy transfer takes place. So based on that, problems are actually designed. Let's say ballistic pendulum or a bullet gets embedded inside a target. There can be a single target, there can be a multiple targets, or there can be a single plank, there can be multiple plank. So kinetic energy of the bullet goes on decreasing. At what point? At some point, the bullet stops. So different style the problem is being asked. What is the resistance offered by the, let's say, army people, they stand with stain gun behind a sandbag. So if somebody fires bullet from the other side, the bullet gets embedded inside the sandbag. So they will ask, you have to apply the work energy theorem, and then they will ask what is if you know the velocity of the bullet, what resistance or force offered by the, there is a deceleration actually, there is a resistance or the force which is being offered by the particular sandbag or plank. So slowly we will be discussing all these points one by one. Thank you. So now let us start from the basic. Motion in a straight line is the motion of an object along a single straight line. Only one coordinate is needed to describe its position. Let it move in any direction, only one coordinate is enough. That is the starting point. Now, motion in a straight line deals with the motion of an object which changes its position with time along a straight line. Anyhow, when a body moves from one place to another place, it will change its position. There will be initial position, there will be final position. So that thing happens first. Now, what is the meaning of rest and motion? See, a numerical problem is asked, a body starts from rest. A body starts from rest means initial velocity will be 0. A body comes to rest. Comes to rest means final velocity will be equal to 0. So, what is the difference? What is the meaning of rest and motion? If the position of a body does not change with time with respect to the surrounding, then it is said to be at rest. It is not changing its position. Newton's first law, the body continues to be in a state of rest. It will be at rest. Or if it is in motion, it will be in motion. Unless and until some force overpowers to change that state. Okay. If not, it is said to be in motion. If it starts moving, it is in motion. Now, you know the difference between what is a scalar quantity, what is a vector quantity. Scalar quantity has got only magnitude. Vector quantity has got magnitude as well as direction. Now, so distance is basically a scalar quantity And displacement is what? The distance traveled in a particular direction. So that is displacement. Now, when you describe the motion of a body, you need to follow certain rules actually. Always the displacement will be more or less than or at sometimes equal to the distance. Distance will always be more. Okay. So distance, total path length traveled. See, a body starts from a point A. It may travel different path and then comes to the point B, new position. So the entire path has to be calculated. That is distance. But the displacement is actually the shortest distance which is covered. Shortest distance between 2 points is a straight line, distance is a scalar quantity. Displacement is the shortest distance from the initial to final position with the direction. It's a vector quantity. So always you should look for some shortest distance. See, always know whatever be the motion, you have to attach a frame of reference. Frame of reference means, as you know that it's nothing but a relative this thing. Everybody in motion. Michelson-Morley, the two physicists, they wanted to actually find out the absolute speed of Earth. Because, when you start calculating the motion of a body, Earth is also moving. It is nothing but relative speed. So, whenever you describe the motion of a body, it is very important you have a coordinate system. Either Cartesian coordinate system or polar coordinate system or spherical polar coordinate system. Some coordinate system has to be there with respect to which the position of a body is actually you can find out. Okay. Now let us, these are the two beautiful example you can see. See here, there the body actually, if you attach a Cartesian coordinate, this is xy coordinate. If you attach a Cartesian coordinate, this is the origin. Now let's say the position of a particle at A is described by its distance from O to A as, let's say, R1. This is the displacement vector. One arrow is there. Sometimes in book it will be written as dark. And let's say the body moves to some position B. With respect to origin, let its position vector be RF. This is the initial position vector. This is the final position vector with respect to origin. Now what is the shortest distance? Shortest distance from A to B is its straight line, del R. Del R means actually this RF minus RI. Del R will be equal to RF minus RI. It can be in dark or you can put an arrow mark on top. So you have to calculate this distance, you have to calculate this distance, you have to subtract, that is your del R. So this is the shortest distance. This will be called as displacement. This will be called as displacement. Displacement. Because it has got the shortest magnitude and it has got some direction. The distance, it can be any path. Now here this red color one path is there. It can be some other path. It can be like this, like this, like this, like this. It can reach there. This is also one path. It can be any path. It has to start at A and it has to reach at B. So then the total distance traveled is called distance. But the displacement is always you have to look for the shortest distance. In coordinate geometry, you know how to find out the shortest distance between two lines. Okay, like that, this is the shortest distance. Here another example is there. This is the start, this is the finish. See, you see the displacement. Displacement is this green line. Green line is the Green line is the displacement, because this is the shortest distance, and the distance traveled will be, see, from here to here, then here, then here, then here, ultimately it is reaching the finish line. It starts from here, then goes here, then takes a perpendicular upturn, then again horizontal it moves perpendicularly, then again vertical, and then at some angle reaches the finish line. So this is a long length covered. This long length covered is distance traveled. So blue line, according to the logic, blue line represents the distance. As simple as that. Okay, so I hope you know the difference between displacement and distance. Now, here some examples are there, simple examples are there. With this the logic you will understand. Now, this looks like a circle, but this is a semicircle. What is the perimeter of a circle? You know, if the radius of the circle is r, the perimeter will be 2 pi into that r. 2 pi r is the total circumference of the circle. So that is the total perimeter is 2 pi r. What is semi perimeter? 2 pi r by 2, that is pi r. So now a particle suppose starts, or a body starts from A and reaches B. If it follows this red line, then that will be distance. So distance is a perimeter, half circle means it is pi r. So pi r is the distance. Now what is the shortest distance from A to B? Shortest distance from A to B is this r plus this r. So r plus r is 2r. So 2r is the displacement. The shortest distance between 2 points in a particular direction will give you displacement. So this particular example, this is the distance and this is the displacement. This is your semi perimeter. Full perimeter is 2 pi r. 2 pi r is the full circle ka perimeter, full circle. Semicircle means by 2 you have to do. So pi r is the distance because it moves like this, red line. Now another example. See, this example, a body goes up and then the body comes down. Let's say from this point to this point, the distance is, height is h. Height is h. So it goes up h distance and it comes down h distance. So if you are calculating the distance, it will be h plus h. It starts from A, goes here and then it comes back to B. This is A and this is B. This is B. It starts from A and then comes back to B. Okay, comes back to B. So h plus h is 2h. 2h is the distance. Why displacement is 0? Because in upward direction it travels h. Then again downward direction it travels h. So plus h minus h will be 0. Plus h minus h will be equal to 0. Okay, if you are throwing something up and it comes back to your hand with the same velocity as it was thrown, then that ignore air resistance or any dissipative forces which are coming in and disturbing the motion. So displacement will going up h, coming down h, positive vector plus h minus h, it will be 0. Now this is another this thing. This example actually both distance and displacement are same, because this block now cannot leave the system. What is the system? It's an inclined plane at an angle some theta. So suppose let's say it is coming down from this point to this point, starting point to end point. Let's say this distance is s. So shortest distance also s. and distance traveled also s. So always remember, distance will be basically greater or equal to displacement. What? See here, distance will be greater or equal to displacement. Why mod is taken? It can be plus or it can be minus. Are you follow? Minus distance is not there. But displacement can be plus, displacement can be minus, you can take the mod. So this particular example gives, gives information that both the distance and displacement is same, SS. Now what about this? Carefully see. See, first, let's say the height of the tower is h. Okay. In upward direction also tower length is h, downward direction also tower height is h. So don't do plus h and minus h and write displacement is equal to 0. Because in this problem from the tower a particle goes up and comes down. And they are asking what is distance and displacement. Problem is that I have not written the question, but the problem is that from the top of a tower you have thrown a body up, it travels a distance x in the upward direction, then comes down that distance x, and then it comes down and covers the height of the tower. So what is the total distance travelled? From here the body goes up x, then it comes down to this particular point, top of the tower, x. So x plus x is 2x, and of course while coming down it has to cover the height of the tower, h. So total distance travelled is h plus 2x, but the displacement in any direction is h. Don't do plus h minus h and put 0, because the problem says that from the top of a tower a particle or a body goes up x distance and then it comes down to the ground. What is the total distance, what is the total displacement. So in that case, if your judicious judgment should be that distance is nothing but this h plus at one particular point, sorry, it starts from here, no. So x plus this h, don't add this h again here. And displacement is the shortest distance, any one HU, right? So these are the three examples which will clearly explain the concept of distance and displacement. And the bottom line is, distance can be equal to displacement sometimes, always, most of the time distance will be greater than displacement. Okay. So very carefully you have to answer the multiple choice when a question is asked. Now, here some example I have given. See, for moving particle, the distance can never be negative, as I told you before. Distance can never be negative or 0, while displacement can be negative or it can be 0. Suppose going up and coming down same distance means plus x minus x, it will be 0. In general, magnitude of displacement is not equal to distance in general. However, it can be so if the motion is along a straight line without change in direction. Without much change in the direction, sometimes it will be equal. Okay, as the previous example, sometimes it will be equal. Okay. Now, here one example is there. Magnitude of displacement is less than the distance travelled in case of a curvilinear motion. Suppose the particle or a body is moving in an arc. So a very good example here. See, this is not don't think that this is because of the positive place constraint, the diagram is looking like a ellipse. Think that this is a circle. This is a circle. Okay. Now, what is the point? What is the problem? The body starts from A and goes to B. So now if this is a circle, let's say the radius of the circle is r, and between A and B it is an arc. It is an arc, and let's say the angle between A and B is theta. Angle between A and B is theta. Angle between that is angle which this this particular sector AB arc angle arc, let's say AB subtends at center B theta. Okay, let's say this angle is theta. So according to the rule, let that arc length be d. So now, actually what you have to imagine is arc will be very small length. So you have to imagine, let's say this is opposite side, this is adjacent side. D is opposite, R is adjacent. You know opposite by adjacent is tan theta. You know old Harry and his old aunt. Old Harry opposite by hypotenuse sin theta and his adjacent by hypotenuse cos theta. Old aunt opposite by adjacent is cos theta, tan theta. So think that D by R is tan theta. Theta is small. So your D will be equal to R theta. Actually D will be equal to R theta. So this distance, if you apply the logic of that arc, the distance will be equal to R theta. But suppose if you drop a perpendicular here, you are dividing this angle theta into two parts. This is theta by 2, this is theta by 2. Now, what is the distance is R theta? What is displacement? Displacement is the shortest distance traveled. Shortest distance traveled is this is x, this is x. X plus x is 2x. Or if you want to write down in terms of trigonometry, then this is opposite side, this is hypotenuse. So opposite by hypotenuse is sin theta, no? So x by r is equal to sin theta by 2. X by r is equal to sin theta by 2. So what is x? Therefore x is equal to r sin theta by 2. So 2 into x, if you put x as r sin theta by 2, it will be 2r sin theta by 2. So in multiple choice, this particular like these cases are asked, then the distance will be r theta, the distance will be r theta. Okay, theta is this. So this d is equal to r theta. I told you, no? Opposite by adjacent is equal to tan theta. Theta is small. So d by r is equal to tan theta. If tan theta is small, then tan theta is almost equal to theta. In mathematics, you know. So therefore, this is the distance, d is equal to r theta. Displacement will be x plus x 2x, or in a trigonometric ratios you can write, this is opposite, this is hypotenuse, x by r is equal to sin theta by 2. So x is equal to r sin theta by 2. So 2x, so 2 into r sin theta. So this is your displacement. Okay. Now, here one example is there. What is this example? An athlete completes one round of a circular track. Suppose this is looking like a perfect circle. So this is circular track. An athlete completes one round of a circular track of a radius r in 40 seconds. So one circle the athlete takes 40 seconds. So what will be his displacement at the end of 2 minutes 20 seconds? He is asking the displacement, not distance. So 2 minutes 20 seconds you convert into seconds. 2 minutes means 1 minute 60 seconds. So 2 minutes 120 seconds. 120 plus 20 is 140 seconds. So one circular arc it takes 40 seconds. So for 140 seconds, how many circular arc it will rotate? 140 divided by 40. Simple mathematics. In 40 seconds, athlete completes one round. So in 140 seconds, athlete will complete 140 by 40, that is 3.5 rounds. Now, very carefully you have to put the logic, you have to think. See, these 3 rounds, you are actually, they are asking displacement. So from where you start and you come to that same point means displacement will be 0. So 3 complete circle, the displacement is 0. Only the question is this half round. If it covers half round, that problem number 1, half round semi-perimeter, this section. So what is the displacement now? R plus R, 2R. That is the radius of the target, diameter of the track. Okay. So you have to, this R plus this R, that is 2R. Why? That is net displacement. Why net displacement? Because 3.5 rounds, in the problem it is given 3.5 rounds. So for 3 rounds, displacement will be 0. Had they asked only 3 rounds, then you should have written the answer 0, displacement. But according to this numerical problem, you got 3.5 rounds. So 3 rounds from the same point and then coming back to same point, 3 rounds, it is displacement is 0. For the next half round, 0.5 rounds, it will cover the shortest distance. Displacement is R plus R, 2R. It is not cancelling out. Just only half circle it is. So this problem, you be careful with this type of problem. Now, what is distance? Total length of the actual path traveled. Okay, actual path may be a long path also. So you have to be very, very careful. Okay, it's a scalar quantity, SI unit is in meter, and always the distance is positive. What about displacement? Shortest distance between initial and the final point. So always you have to look for the shortest distance. And it's a vector quantity. Why it's a vector quantity? Because the direction is involved. And of course its SI unit is meter, and it can be positive or it can be negative or it can be 0. Positive means going up, negative means coming down, and both positive and negative is involved, length is same, then it will be 0.